Let's take a look at this one here. We're given basically a piecewise defined function. The function g of x is defined by this rule for all inputs that are less than -1, and by this rule for all inputs that are greater than -1. So let's find the limit as x approaches -1 from the positive side. So that plus sign means that we're approaching from the positive side, or from the right, if you will. So if we're looking at a real number line, and here is x is equal to -1, what's happening to the function as we approach it from above? So, like at 0, -0.5, and so on. Well, if x is greater than -1, right, from the positive side, then this is the rule. So this limit is the same as the limit as x approaches -1 from the positive side of 5x plus 8. Well, 5x plus 8 is just a linear function. It's continuous on its domain. Of course, we're only using this rule for values of x greater than -1, but as we approach -1 from the positive side, the function is always 5x plus 8. So I can use direct substitution by plugging in x is -1 here. Of course, I get -5 plus 8, I get 3, right? Graphically, what's happening, if I wanted to look at this, so here's -1, here's the y-axis, 1, 2, 3, right? The graph of this function looks like this. At -1, of course, there's a hole right here at 3 where we're approaching, and the line is 5x plus 1, so it's a very steep line. It looks something like this, right? Slope is 5, right? So as we're approaching, as we're getting closer and closer to -1, the x value, where are we going to on this line? We're going right to the coordinates of this hole that has a y value of 3. Okay, so that's from the positive side. What about from the left? What's happening from the left? Well, from the left, we've got this rule, 3x squared plus 1. So the limit as x approaches -1 from the negative side is the limit as x approaches -1 from the negative side of 3x squared plus 1. Well, 3x squared plus 1 is a quadratic function, but it's continuous on its domain, so we can plug in directly. And if I square -1, I get +1. 3 times 1 is 3, plus 1 is 4. Right? So if I'm looking over here now, this graph, 3x squared plus 1, it is approaching 4. Put a hole right there at 4, and it's the graph 3x squared plus 1, so it's part of a parabola. If we kind of drew the entire parabola, it would look something like 3x squared plus 1 is just 3x squared shifted up 1 unit, so it's the y-intercept is at 1, and then we go up this way. But it's not the whole domain, it's just for values less than -1. So values less than -1 would be just this part here, and it's approaching, right, as we get close to -1 from the negative side. Where are we going to? We're going right to the coordinates of that hole, which have a y value of 4. Okay, so the limit, again, you don't have to draw the picture here like I did. I'm just trying to show visually what's going on. Algebraically is fine. There's the support. Simple. There's not much to it, right? Because these are continuous functions. However, now we get to the last question. What is the limit as x approaches -1 for the function g of x? Well, notice the limit from the right, from the positive side, is 3. The limit from the left, negative side, is 4. Since these two limits are not equal, we know that this limit does not exist. If both these limits were equal, then the limit would be equal to that same value. And the problem is we've got a discontinuity. We've got a jump discontinuity here, a break in the graph. If it was continuous, these two parts would have to connect together, right, to make it continuous, so that there was no gap, no jump at all. Okay, so very simple. Finding the limit in this situation. Hopefully this is helpful for you.